Hi all, the topic is Newton-Raphson method. The aim of this Python program is using Newton-Raphson method find the real root correct to 3 decimal places equation sin of x is equal to x by 2 given that the root lies between pi by 2 and pi. The theory behind this program is the Newton-Raphson method. This method is generally used to improve the result obtained by another methods to get roots. Let x0 be an approximate root of f of x is equal to 0 and let x1 is equal to x0 plus h be the correct root so that f of x1 is equal to 0. Expanding f of x0 plus h by Taylor series, f of x0 plus h into f dash of x0 plus h square by 2 factorial into f double dash of x0 plus etc. which is equal to 0. Neglecting the second and higher order derivatives. Therefore, f of x0 plus h into f dash of x0 which is equal to 0. Therefore, h is equal to minus f of x0 divided by f dash of x0. A better approximation than x0 is therefore given by x1, where x1 is equal to x0 minus f of x0 divided by f dash of x0. Successive approximations are given by x2, x3, etc. to x of n plus 1, where x of n plus 1 is equal to xn minus f of xn divided by f dash of xn, which is the Newton-Raphson formula. From iterative method, x of n plus 1 is equal to phi of xn. Therefore, phi of x is equal to x minus f of x divided by f dash of x, and phi dash of x is equal to f of x into f double dash of x divided by f of x all square. To examine the convergence, we assume that f of x, f dash of x and f double dash of x are continuous and bounded on any interval containing the root x is equal to sigma of equation f of x is equal to 0. If lambda is simple root, then f dash of x is not is equal to 0. Further, since f dash s is continuous, f dash of x is greater than or is equal to e for some e is greater than 0 is suitable. Is a suitable neighbor of lambda. We can select an interval such that if f of x into f dash of x is less than e square, and since f of x is continuously twice differentiable, hence in this interval we have phi dash of x is less than 1. Newton-Raphson method is an open approach where optimum of one-dimensional function f of x is found using an initial guess of optimal value without specifying lower or upper boundary values. We can find the minimum and maximum of a function f of x. Before using Newton-Raphson method, to determine the minimum maximum of a function, only should have a reasonably good estimate of the solution to ensure convergence, and that the function should be easily twice differentiable. Next, the algorithm. Step 1. Define a function fn of x. Here the function is sin x minus x by 2. And step 2 is x1 is equal to read the value of x1 from user. Step 3 is equal to define the value of h is equal to 0.01. And step 4 is n is equal to read number of iteration. And step 5 is for I in range of n, do the step 6 to 11. And step 6 is y1 is equal to fn of x1 minus h by 2. And step 7 is y2 equal to fn of x1 plus h by 2. And step 8 is slope is equal to y2 minus y1 divided by h. And step 9 is equal to x2 is equal to x1 minus fn of x1 divided by slope. And the next step, step 10 equal to make x1 is equal to x2, and step 11 is equal to print the values of x2 and f of x2. Then last step, step 12 is equal to print the correct root as x2. This is all about the algorithm. Then the program. Program is from math import star, from pylab import star, define fn of x. That is the function is defined. Then return sin x minus x by 2. Sin x minus x by 2 is our given function. Then x1 is equal to input, enter the value of x1, h is equal to 0.01, n equal to input how many iteration. Then for I in range, y1 is equal to fn of x1 minus h by 2. Then y2 is equal to fn of x1 plus h by 2. Then slope is equal to y2 minus y1 divided by h. Then x2 is equal to x1 minus fn of x1 divided by slope. Then x1 is equal to x2 and print x2 and fn of x2. Then print correct root is x2. This is the function. This is the program. Then the result is the program for Newton-Raphson method to find root of an equation is executed and the output is obtained. Then using this program we can get the output and the program is executed. This is all about the topic. Thank you.